So I believe it is Luke Sunblad that changes my background on me. Do you know who that is? Jack Nicholson from the movie The Shining, which is a book by Stephen King. One of the most classic Jack movies of all time. It is quite the movie. Be ready to be disturbed when you watch it. Here's Johnny. All work and no play makes Jack a dull boy. Remember, he's working on his novel for months. And then finally his wife goes and checks to see, and every page is all work and no play makes Jack a dull boy. And at that point, he realizes he's gone crazy. So, here we go. 1 minus cosine squared times cosecant. This is slightly different from yesterday. We're not going to give you as many hints. We got to be able to just work through them, okay? So we start here. 1 minus cosine squared times cosecant. What? There you go. So, now we don't have a squared. Okay, we've got 1 minus cosine times 1 plus cosine. 1 minus cosine times 1 plus cosine. Good. Okay, so Scott foils it out, and he says, I don't have a squared right now, but maybe I could create it if I multiply it through. So he's going to foil this out. 1 times 1 is 1. 1 times cosine is cosine of theta. Negative cosine of theta times 1 is negative cosine. And then I get negative cosine squared. What do you notice? They cancel. Which is? This is that point where you want something to pop into your brain where you say, okay, I've seen this before. Sine squared. So that comes from this sheet. If you look at number 5, we've got sine squared equals 1 minus cosine squared. Okay? Now, the relationship between these two pieces are that they are conjugates. And conjugates, if she comes back, relationship between conjugates. What's a conjugate in Spanish? Change ending. So you can see here that the ending changes. It goes from negative to positive. And when you change the ending of a binomial in mathematics and you multiply together, the middles will cancel. So if you see something like this, you don't have to quite multiply everything out. You can realize the middles are going to cancel. You're just going to get tangent times tangent, which is tangent squared. And then you're going to get secant times negative secant, which is right. So if you see that they are conjugates, don't worry about the middles. They go away. Tangent squared minus secant squared. It's not 1. It's close. It's negative 1. So you can see that secant squared minus tangent squared is positive 1. If I would solve for that differently, here I've subtracted a 1, and I got tangent squared is secant squared minus 1. And then I subtracted the secant over to get tangent squared minus secant squared. You can see that that's negative 1. So I don't have every formula written on the board, but I've got a decent number to choose from, and maybe you can work to express the rest. So this is negative 1. How about G? What's different about that? It has 2's. They're still conjugates, aren't they? So I'll multiply. I'll get 4 secant squared minus 4. Now, you don't have a formula for 4 secant squared minus 4, right? Factor out a 4. 4 times the quantity secant squared of theta minus 1. Secant squared minus 1. So this is 4 tangent squared. H, we got cosine tan plus cotangent times cosine. Okay, so no more hints the rest of the way, really. You've seen, kind of these different operations. Now we just gotta come up with our own idea. What will be your strategy here? What will be your first step? Any thoughts? Okay, good. Scott sees that if you change tangent to sine of theta over cosine of theta, you're going to end up with the cosines canceling. That's a good strategy. If we're going to change it to sine and cosine, let's do that all the way through. And instead of cotangent, you'll have cosine of theta over sine of theta times cosine of theta over 1. Cosines cancel. What do you end up with on the left-hand, right-hand side? We've got this cosine squared. Right here, all we have is sine of theta over 1. And on this right-hand side, we have cosine squared over sine. It's nice to come up with a squared, because something might simplify. We might be able to insert some type of formula. Well, these are two fractions. I could take a shot at combining them together. In order to add two fractions, I have to have common denominators, so I multiply top and bottom by sine what does this give me? Sine squared. Over sine. Cosine squared. Over sine. Do they now have the same denominator? So let's add the numerators together. What is sine squared plus cosine squared? 1. If you remember from your sheet, it says sine squared plus cosine squared is equal to 1. And I have sine in the denominator. What's 1 over sine? Cosecant. Kind of tricky, huh? See if I follows almost identical to H. See if you can get a start on I. It works out very, very similarly to H. So you can just, take a minute and a half, 2 minutes at it. See where you can get. Let's see where you got. That's the idea. Sine squared of theta over 1 times 1 over cosine. Everybody wrote it like that. And then cosine of theta over 1. Now we combine them together. Sine squared of theta over cosine plus cosine of theta over 1. What's your common denominator? Cosine. So you multiply top and bottom by cosine. Whoop. No squared. And you can see you get sine squared plus cosine squared over cosine of theta. What was sine squared plus cosine squared? 1. And you have cosine in the denominator. 1 over cosine is secant. So follows very similar to exactly how that one worked out. Okay. Zach, you look like you got a question. That's all right. We'll give you one to practice for the assignment. How's that? Okay, same approach for I, or for J. I got a 1 here. I like that. Boy, if I came up with a squared over here, life would be pretty good. But I don't know what cosine times sine times tangent is, so maybe our best bet is to just write everything in terms of sine and cosine. So tangent is sine over cosine. If I write it like that, what happens? Your cosines cancel. So on the left side, I've got 1 minus, and what do I have on the right side? Sine squared. What's 1 minus sine squared? Isn't that nice? You like that one, don't you? That would be one where if I put it on the test, I would say if I put 2 problems on the test, say one that was a little bit easier, one that was a little bit harder, that would be an example of what I would choose for one that's easier. I will not put one like A on the test. We did really this front page to prepare to be able to do problems like this. You know, changing in terms of sine and cosine, that would be 1 point for that problem, doing that. But I really want you to be able to work through that type of problem. And I think that you can. Okay? All right, we have 4 more problems to do. We're going to do these 2. They go pretty quick. And then we have 2 more to add just for practice purpose. In the previous years, they've gotten a little confused if we haven't added these. So, number 11, cosine squared plus cosine squared times cotangent squared. Often, you don't have to write this down because this isn't the correct way to do the problem. But a lot of people, when they do this type of problem, they write it out like this. Does that help me out? You get cosine to the 4th over sine squared. That's not really helpful, is it? So changing it to terms of sine and cosine really didn't help at all there. Okay? What's that? Factor out a cosine squared. We saw this kind of example earlier. I put it back in here to see if, you know, if you'd remember that. When I factor out a cosine squared, what are you left with here? 1 plus, and what are you left with here? Cotangent squared. Very good. So at this moment, right, you know, your attention should be drawn to what? 1 plus cotangent squared. You see a 1 and you see something squared and you say, hey, I like that. I think I remember that. That is something from number 7. 1 plus cotangent squared is cosecant squared. So we have cosine squared times cosecant squared. Hey there, bud. We missed you. Now that I have cosecant, maybe if I rewrite that in terms of sine and cosine, I'll be able to simplify it a little bit. Cosine squared of theta over 1 times, how can you rewrite cosecant? 1 over sine squared of theta. Cosine over sine simplifies to cotangent. So this is cotangent squared of theta. Okay, number 12, I think everybody knows we're going to distribute through here. But your attention should be drawn to some type of relationship when you do distribute through. What do you notice is interesting as I multiply through here? What do you notice about the cosecant? It's the reciprocal of sine. And when you multiply two reciprocals, you get 1. So let's do it. 1 times sine, I'm sorry, cosecant times sine is 1, because they are reciprocals. Then if you take cosecant times sine times cosine squared, the sine and the cosine, yes. And then they cancel. Either way is fine. Either way is fine. Yep, 100%. As I distribute, the cosecant times the sine gives you 1, leaving you with just the cosine squared. If this light bulb goes off and you say, yay, 1 minus cosine squared is sine squared. Very good. Okay, so we're going to add 2 problems. The first one's going to go quick. The second one takes a little while. Add this to the bottom. Yes, you notice that the instead of theta, it's an x. What was that? Does that sound like a phone? So, I don't know what I heard. Oh. Oh. All right. Okay. Well, no, I don't always turn my phone off. I thought maybe my phone went off as one of my wife might be calling me, or who knows. All right, so it doesn't matter if you change the theta to an x. You could have a u, you could have a z. It doesn't matter what the variable is. It does matter that it is negative, okay? It does matter that it is negative. I want you to turn in your notes, and I want you to not look at the page that we've been looking at, but I want you to look at a different one. This one right here. You see this one? Our attention is going to now start to draw to this from time to time. We got to get familiar. I would encourage you to take a highlighter or a colored pencil or crayon and start boxing them in different colors, because on the test you're going to have to know which one you want to go to. All right, and sometimes color helps that stand out a little bit. That's what I would do. Okay. Yeah. So if you look at the one that says even and odd identities, you see those negative angles in there. And we never like to leave a negative angle in trigonometry. And so it says sine of a negative angle is equal to negative sine of that angle. All right? Let me just show you real quick why that works. Don't write this down, but let's just understand real quick. Sine is positive in which quadrants? First, second, and it's negative down here. So sine, if I take a positive angle and I go up, okay, it's positive. But if I do that same angle in the opposite direction, a negative angle, you can see it turns from positive to negative. Watch tangent. Oh, I did? We'll rewrite it. You guys wrote it down. Okay, so tangent, if you take the angle like this, but instead you go in the opposite direction, you can see it goes from positive to negative. Watch what happens with cosine. Cosine is positive in the first and the fourth. It's negative in the second and third. Cosine, if you take an angle, but you decide to go in the opposite direction, does it change from positive to negative? No. You're like, well, what if you went 2 quadrants? Well, if I go 2 quadrants, it becomes negative. If you go 2 quadrants the other way, it's still negative. So cosine doesn't change. Okay? So what we do is we take our trig values, our trig functions, which we had, I think we had cotangent of x, is that correct? minus sine of negative x plus cotangent of negative x. Let's change it so we don't have any negative angles. I change it so I don't have any negative angles. Instead of a minus sine of negative x, I would have minus a negative sine of positive x, or plus. And instead of plus cotangent of negative x, I would have minus cotangent of x. And I changed that according to those formulas put there on your sheet. That's the relationship. And so what do you notice happens now? The cotangents go away and leaves you with sine of x. You probably really like that problem. All right. Thank you, Taylor. What's that? This one? Because there was no negative angle. Here you had negative angles. All right, last problem. There you go. 1 plus secant over sine of x plus tangent of x. You're going to want to find a space where you've got a decent amount of room. So whether you do it on a back page or whether you do it anywhere, but we need to find some room for this one, okay? I would say that this would be the hardest type of problem I would ask you for your test, okay? This would be the most difficult problem you see for your test. Your extra credit could definitely be more difficult than this. Yeah. That's why it's called extra credit. So, all right. This is very similar to one you have in your assignment. Okay. That's why we're working through it. Prepare you for that. A lot of people see the 1 plus secant, and when they see 1 plus secant, their attention gets turned to here. Okay, they see a 1 and a secant, but it's secant squared, everybody. And so some people want to just put a tangent in there. It does not work like that. You can't do that. When in doubt, turn everything in terms of sine and cosine, especially if you don't have a squared. And so I'm going to write this as 1 over 1 plus 1 over cosine of x over sine of x over 1 plus sine of x over cosine of x. This is a complex fraction. Just got done doing it next door. Just had a test on it. And I'm sure some people were kind of chirping and saying, well, when are we ever going to use that? Well, you're going to use it when you get to trig. You're going to have to simplify this stuff all the time. Okay? And then you're going to do it again in calculus. We've got to be able to handle this. In order to simplify complex fractions, I first make one fraction in the top, one fraction in the bottom, and then I multiply by the reciprocal when I finally simplify it. So that's what we want to do. What is our common denominator going to be in the top? Times cosine of x over cosine of x. That way I have a cosine of x in both denominators here. What's going to be the common denominator in the bottom? Cosine of x. Notice that you have the same denominator in the top and the bottom. So when I multiply by the reciprocal, what's going to happen? They will cancel. So again, that foresight is important. Okay? So let's write out what we got. Cosine of x times 1 is cosine of x. Then I have a plus 1. And what is the denominator? Cosine of x. Over, what's cosine of x times sine of x? It's just cosine of x, sine of x, plus sine of x over, what's the denominator? Cosine of x. I got two fractions, one on top of the other, Now what? Multiply by the reciprocal. Get rid of that. Times cosine of x over cosine of x, sine of x, plus sine of x. What do you notice? Where? Oh, what? Oh, this one? This one is still right here. I'm multiplying by the reciprocal of the bottom. So what happens? Those cancel. Now, wouldn't it be nice if I had a cosine of x plus 1 in the denominator here? I could get that, can't I? By factoring out a sine. So, we do our last step. On the top, I have cosine of x plus 1. And on the bottom, I have cosine of x times sine of x plus sine of x. Whoop, I'm sorry. We said we were going to factor it out. I'll just do that right now. You guys already said it. Cosine of x plus 1. Is it okay to now cancel them off? Yep, they're not separated by addition or subtraction with the sign, so I can do that. And I get 1 over sine of x, which is cosecant. I agree, that's a challenging problem. Okay, so this was the assignment. Okay, I told everybody, I said, let's just finish off all the problems through 22. This is what you should have done before from your past couple days. This is the rest through 22. So on that section 7.1, there's 22 problems that involve simplifying. I want to be clear. I thought I said this before. I don't expect that everybody would come out with all of these problems correct. It would be, I would be teacher of the year if I got all my students to be able to do every single one of those problems correctly. Okay? It's just not realistic. Okay? But without a doubt, you all should be able to try to get the problem started and see if you can, get to a spot where you're like, okay, that worked, that didn't, and I can help you through some of those pieces tomorrow, okay? Or even the last part of today. So, last hour we looked at example 19 and 14, I think is what we did. Was that it, Caitlin? Is that the one you were having a question? We can look at 19. If you guys like me to, let me stop this video.